Okay, now let's solve these IVP problems. It's going to be very similar to the other exact equation or PDE problems. The first step, we're gonna solve this PDE equation, and then we're gonna get the solution for this PDE or ODE equation. Okay, ODE equation, and then we're gonna plug in the initial condition to get the constant. Okay, so let's take a look the equation. Here we have m equals y cubed minus 1 e to the power x. N is equals 3y squared ex plus 1. Okay, ex plus 1. And now we're going to check partial m over partial y. Okay, partial m over partial y. So do the derivative with respect to the y, treat the other terms with the constant. So basically, we do the derivative for this term, and treat this one is a constant, right? So we have 3y squared e to the power x. And again, we're gonna do the derivative for this guy with respect to the x. Okay, so basically we treat this 3y squared as a constant, and treat this term, do the derivative for this term. E to the derivative of e to the power x is gonna be itself. Derivative of 1 is 0, right? So we have, okay, so we're gonna get these two equals each other. What does that mean? That means it is exact equation. Okay, we just need to follow the procedures of the exact equation. Now let's take a look. Partial f over partial x equals m. M is y cubed, right? And f gonna have what? F gonna have dx, integral of this guy, and treat this guy is constant. So we have integral of e to the power x equals itself. Okay, and then for the second term, partial f over partial y equals n. N is 3y squared e to the power x plus 1. Okay, and again we're gonna do the integral with respect to the y. We have this guy, and we move the constant out of the integral, right? And we have 3ex plus 1, right? We move this term and the two terms out of integral, and then we have the integral of y squared gonna be y cubed divided by 3, right? And then we're gonna get cancel out y cube ex plus 1. Okay, y cube, yeah, ex plus 1. Okay, so now we want to pick the terms from these equations, and actually for this integral, the first integral, we can continue to simplify it. We can write down these terms, right? And for this guy, we can write down as, we do the expansion because we want to try to find the common terms, pick up all the terms necessary. So the solution gonna be, we have a repetition term is y cubed e to the power x. Non-repetition term is negative ex plus y cubed. equals C. Okay, equals C. So that's the solution for the ODE. Okay. Okay. Now we're gonna plug in the initial conditions. For this problem, we know the initial condition is y0 equals 2. So that means when x equals 0, y equals 2. Okay, equals 2. So let's plug in the initial condition. When x equals 0, y equals 2. Okay, and basically we can solve it. So this is 8 minus 1 plus 8, so 16, 15. Okay, 15. So the solution for the IVP is y cubed e to the power x minus e to the power x plus y cubed equals 15. Okay. Here is not enough for some requirements of the format. Okay, so usually people would like to you write down as y equals what kind of x expression, okay, or implicit expression. So how to write down the explicit expression for the solution? So for this case, we are very lucky. We know here we have y cubed. So we can write down as factor y cubed is like that. Okay, like that. And then we write down, move this term to the right, and divide by this coefficient, and we know the cubic root gonna be like that. Okay, so that's the solution for the IVP. That's it.